so this week we're going to be talking about how electrical energy can be converted or changed into heat. Dylan, you need to sit up and you need to listen. So do you think that it's important that someone figured out how to change electricity into heat?
Yes.
Okay, obviously we saw a picture of a toaster, so you know we're going to be talking about toasters. But what else would use electrical energy or electricity and turn it to heat? What's another example? Christopher? A heater. Owen?
A microwave.
A microwave, okay. What else? Olivia?
A coffee machine.
Okay, yeah, coffee pots have to heat up the water. Amy?
Air fryer.
Okay, very good. Scotty?
A stove.
Stove. Harper?
Does anyone say microwave?
Yes. That's all right. Katie?
An oven.
An oven. Jacob?
One of those boiler things.
Okay.
In the kitchen.
Christopher?
An electric smelter.
Okay. Briley?
A washing machine.
Washing machine doesn't use heat, but what would?
Dryer.
A dryer does, so if it's an electric dryer. Okay, what about, now something that the washing machine does rely on, it doesn't actually make the water hot, but there is another appliance that heats up water. What is it?
Kettle. Ooh, a boiler. Dishwasher.
Okay, a dishwasher does heat the water, have hot water running through it too, but what makes the water hot? When I turn on the faucet in the shower and I want hot water, a hot water heater, do you think that's a pretty important thing? Who likes cold showers? Not me either.
I took a cold shower the other day.
Okay, listen please. There's way too many people talking at once. Thank you for raising your hand, Christopher.
We have one of those, and sometimes we'll leave water in the sink, or we'll be playing with it, and it's full, and the thing makes noises, and it always sounds like it's gonna go.
Okay. All right, so it took a while to figure out how to convert or change electrical energy into heat. And a toaster is a really pretty simple appliance that sends that electric current through a circuit, which is either completed or broken by the switch or the lever that you push up and down or down to make the toast, and then it pops up when it's finished and breaks the circuit. So we're going to be talking about that this week. We've got 3 vocabulary words today. The first one is a circuit. I mentioned that word just a second ago. A circuit is a loop or a path through which an electric current flows. So let's think about a toaster. Okay? If I plug in a toaster, what does plugging it in do?
Turns it on. Turns with electricity.
It takes the electricity that's flowing through the wires to the outlets, and it's taking that electricity, it's letting it flow, and then when I put some bread in my toaster and I push it down, that completes the circuit. That completes the circuit for it to change that electrical energy to heat. Then when the toast is done, what happens? It pops up. And when it pops up, it's just like a light switch. That lever that you push down pops up, which breaks the circuit, and it quits letting electricity flow. Okay, so the next vocabulary word we have is electric current, and that's just the flow of electricity. That's how electricity moves. And then we have the switch, just a part of a circuit that starts or stops the flow of the electric current. So we talked about how that works in a toaster. Where else would we have a switch that would start or stop the flow of electric current? Olivia?
For light bulbs.
Yeah, we have light switches, don't we? If I turn the switch on, that starts the current or the circuit. It allows the electricity to flow, which makes the lights come on. Give me another example, Christopher.
You're like dishwasher or like dryer or something, because you can turn that knob and restart it, but then you can turn it to the off and it'll.
Yes, and sometimes it's not exactly a switch, like a light switch that we flip up and down, but it has some type of button or knob. You're exactly right. Okay, give me another example, Justice. Okay, you're right. Sinks do have an on and off knob, but is that electricity?
No.
No,
It's really not.
it's not. That's uses something different.
The hot water heater.
Yes, it might use the water which comes from the hot water heater, but there's no actual electricity flowing through our sink. In fact, electricity and water are very dangerous when they get mixed.
How? Yes, they
Because water is
conductor.
it's a conductor, and it conducts the electricity and can be very dangerous.
Water, not electricity. I know water.
All right, yes, sir, Caden. Thank you for raising your hand instead of interrupting.
I was also, I went, and we were driving our little cars around here, and I went to see to wash them off, and I really got there.
Okay. All right. So let's read about how toasters work. It says you probably think a toaster is a very simple appliance. After all, the only thing it does is make toast.
It does. There's something going on over here.
Okay. It's true that compared to televisions and computers, toasters are pretty simple. When you push down the lever on a toaster, a switch completes a circuit that sends electric current flowing through the appliance. But would you guess that inventors had a very hard time inventing a toaster? In fact, it took many years to figure out a way to make a toaster that wouldn't melt or burst into flames. That would be pretty bad, wouldn't it?
I'd be terrified.
That would be.
It would be like,
All right, so I'm not going to talk over you. I know it's Monday morning, but we've got to get control. All right, so let's take a look at the questions you have today. You've got a picture here of a toaster.
That's the same toaster I have on my house.
Yeah, here's a toaster. And you have them labeled.
The wires look like
Okay, so let's look here. So the number 1 here, you can see where the arrow's pointing.
The arrow pointing down the floor.
Okay, is that the source of electric power, the switch, or the electric current? What would number 1 be pointing to? The source of electricity, the switch, or the electric current? Which one is it, Amy? The source. That's where the actual electricity is going to be coming from. Okay, then we have number 2 down here. Is number 2, we've already found the source of electric current or electric power. Is it the switch or is it the electric current? What is number 2 going to be, Olivia?
The electric current.
That's the electric current. That's where it's flowing through. So that leaves us with number 3. That's the lever that you push down to make the toast work. So what would we call that?
Lever.
What is it? Switch. It's the switch. It's actually in a toaster. It is the lever that we push down, but that's the switch that starts or stops the flow of electricity.
So once it's up, it stops it. Once it's down, it starts.
You're exactly right. When it's finished, it pops up, which stops or breaks the current. Okay. So what is the loop or the path along which an electric current flows? What do we call that loop or path that the electric current flows? What's that called, Scotty? Source of electricity, circuit, or electric current? When the loop or path that carries the electric current. What?
The middle one.
The circuits. Yes, that's the circuits. No, that's one of your vocabulary words. Okay? Then you have the flow of electricity. Is that called the source of electricity? The electric current? The circuit. What is the flow of electricity known as, Olivia?
The electric current.
Okay, very good. The flow of electricity is an electric current. And then the part of the circuit that stops or starts the flow of electric current is what, Kaden? That's the switch. Very good. Okay, so then you have an open response question. Most levers on toasters automatically pop up when the toast is done. Why do you think that happens? You're going to type a sentence here to tell why that happens. Now remember, on an open response, it's going to automatically give you 0 points, right? And then I'll have to go in and add your points if your answer is correct. I want you to go and complete your daily science for today.